So today's lesson, we're finally into our quadratic equations. Our three learning objectives for today are going to be able to solve quadratic equations using our square root property. We're going to be learning how to complete the square, and then we'll also be learning how to use our quadratic formula. So let's begin. I might have two students read this for me. Let's see. Jalen, I'll have you read the blue, and Jaden, I'll have you read the yellow.
A quadratic equation a squared plus bx plus c equals 0 when quadratic equations differ from linear equations by including a quadratic term with a variable raised to the second power of the form x squared. We use different methods to solve quadratic equations than linear equations because just adding, subtracting, and finding dividing terms will not isolate the variable.
Thank you. Good, thank you. So first objective, using our square root property. This is the most straightforward, and when we get into completing the square, we're gonna eventually use square root property within completing the square to find your possible values of x. But what do you do here? All you do is, if you have your left-hand side all squared, then in order to reverse engineer it, you take the square root of both sides in order to get your possible solutions of what x could possibly be. So key in square root property is just isolating that square. Then you can take the square root and then go from there. You also want to be able to check each solution to make sure that both solutions do indeed work. So let's jump into this first example. We have 3. Our part A, we're asking to utilize the square root property for x squared equals 5. So what do? X squared is already isolated, so we just jump into taking the square root of both sides, which means our two solutions are plus or minus square root of 5, and we're done. In these very straightforward and simple examples, you technically don't really have to check, because if you just look at this and you square it, you're obviously going to get 5 again. So I guess you can check, but it takes half a second. All right, let's jump into B. We're now looking at 3z squared is equal to 108. Let's first isolate the z squared by dividing both sides by 3. And 3 goes into 108. How many times? I want to say it goes in 4. Nope. 33, 36. Yeah. Having a little brain fart today. So yeah, we have z squared is equal to 36. And now, since the z squared is isolated, we can go ahead and take the square root of both sides. So we're looking at our z is equal to plus or minus 6. If you were to plug this back in, let's plug in positive 6, square it, you get 36 times 3, 108, that works. Negative 6 squared, you get positive 36 times 3, 108, good. And then finally, our part C, we have x minus 4 in parentheses squared is equal to 5. The square is indeed isolated, so we just jump straight into taking the square root of both sides. So we're looking at x minus 4 is equal to, you don't want to forget the plus or minus in front of that square root. Anytime you're dealing with quadratics, we have two solutions. And then the last step is we want to get that x all by itself. So we're going to add 4 to both sides. So our final solution is x is equal to 4 plus or minus square root of 5. And we're done. If you were to plug this in, let's look at the 4 plus square root of 5. We subtract 4 from that. We just get positive square root of 5. And if we square that, we end up with 5. So that works. If we plugged in 4 minus square root of 5, well, the minus 4 makes that cancel out. We square negative square root of 5, and we once again get positive 5. So that one also works. All right. Any questions at all? How are you guys feeling on this? Good so far? Yeah. Okay. Let's move on to example 2. So we're going to utilize our square root property to solve each quadratic equation. And we have 2 parts here. Part A, we have 2/3 u squared plus 5 equals 17. Part B, we have 2x squared minus 8 is equal to 41. So again, square root property, we need to isolate that square root. So in that first example, let's subtract 5 from both sides. So we're looking at 2/3 u squared is really the same as 2 u squared all over 3. And then 17 minus 5 gives us 12. The reason why I wanted to put it in that form for the fraction is because now you can easily identify, oh, let me just now multiply both sides by 3 so I can cancel that 3 out. And I'm looking at 2u squared is equal to 36. And then we can go ahead and divide both sides by 2. So we essentially have u squared is equal to 18. Now that it's isolated, utilize the square root property and take the square root of both sides. And the square root of 18 can be broken up into square root of 9, square root of 2. We know square root of 9 is 3. Square root of 2 can't be simplified further. So our final answer is just plus or minus 3 square root of 2. Let's look at part B. We're going to go ahead and add 8 to both sides. So we get 2x squared is equal to 49. And then we are going to divide both sides by 2. So we get x squared is equal to 24.5. Not a nice number. Let's put that into a fraction. So 24.5 is the same as, we'll just keep it at 49 over 2. The reason why is when we take the square root of both sides, we can take the square root of the numerator and the denominator separately. And the square root of 49 happens to be a perfect square. So we get x is equal to, again, don't forget the plus or minus. You don't have to put a plus or minus twice when you break it up, because that sort of defeats the purpose. But we end up with plus or minus 7 over the square root of 2. And then the last step is we cannot have a square root in the denominator, so we need to rationalize that denominator by multiplying by that fancy form of 1. So our final answer is plus or minus 7 square root of 2 all over 2. And we're done. Any questions at all? So that was our first objective, utilizing square root property. Now we're going to jump into completing the square. We're going to start off nice and easy, and then we'll end up with solving quadratic equations by utilizing completing the square, which involves our knowledge of square root property as well. So I might have a student read this for me. Gabriella, do you think you can read this for me?
As we saw in the previous examples, if a quadratic equation is of the form x plus or negative a squared equals c, then we can solve it by taking the square root of each side. In an equation of this form, the left-hand side is a perfect square, the square of a linear expression in x. So if a quadratic equation does not factor quickly, then we can solve it by completing the square.
Good, thank you. This next slide is just the step-by-step procedure in completing the square. It may look a little confusing, so I'll try to make it a little easier for you guys. The thing that I like to think about when we complete the square is just having this special key that we call b over 2 in parentheses squared. And what is in the parentheses is just as important as when we eventually square it. So both the yellow and the blue, it's important to know both of those values, the b over 2 simplified and the b over 2 in parentheses simplified. That yellow is going to make our lives like 100 times easier when we have to factor the quadratic. But that blue is how we manipulate into completing the square. And so what do we do with this special key? We end up adding it to both sides. And I don't want to talk too much on this slide because I think it's better to show you through a concrete example. But the whole purpose of completing the square is literally in the name, right? We know that any square in life has identical sides. So if we have a quadratic function representing the area of the square, how do we complete it? By finding the binomials that we can multiply together to get that area, where those binomials are identical to one another, a plus b and a plus b. And actually, why don't I use x and y? Because I don't want you to trip the variables up with the general quadratic formula. And then another thing to keep in mind anytime we're dealing with quadratic formulas, really have the general quadratic formula in your mind. Because this b value is the b value that goes in here. Okay. So let's do some examples. Now, again, we're starting off easy. So all we're doing is we just need to turn these into perfect square trinomials, meaning we're going to utilize this special key to find what is the constant that we need to add to this binomial in order to get a perfect square trinomial. All you have to do is identify the b value, plug it in here, and then that's your answer. We're going to do that 3 times together. First time, our b is negative 26. Let's plug it into our special key. So we're looking at negative 26 over 2 in parentheses squared. which tells us that our yellow is simplified to what? Negative 13 in parentheses squared. And that turns into our blue, which is just 169. So what does that mean? If we add 169, then we officially have our perfect square trinomial. And we're done. Probably asking, what's the importance of the yellow? Well, the yellow tells us, okay, how does this factor? This, what we have boxed in red, is the same as x minus 13 in parentheses x minus 13, aka our x yellow. But we'll focus on that last part in future examples. We just want to get to red right now. Let's look at part B. Y squared minus 9y. Our B value is negative 9 here. Special key, negative 9 divided by 2 in parentheses squared. And so negative 9 squared is 81. 2 squared is 4. That's our special number that we're adding. And so what do we end up getting? Y squared minus 9y plus 81 over 4. And we're done. Again, if we wanted to figure out what the factored form is, x minus 9 over 2 in parentheses x minus 9 over 2. And last but not least, we have n squared plus 1/2 n. And then we're going to go ahead and figure out our b value, which is 1/2. Divide it by 2, and then square it. 2 as a fraction is 2 over 1. So 1/2 divided by 2 is just 1/4. And 1/4 squared is 1/16. So our final result is n squared plus 1/2 n plus 1 over 16. If you once again wanted to factor, that's just n plus 1/4 in parentheses n plus 1/4. Right. This question was just asking for the boxed answers. Right below the boxed is me taking it that next step further. Questions on this? This is a section where you really, really need to practice it on your own or else you won't get it. So after class today, I highly recommend you spending an hour or two revisiting this lesson and doing additional practice exercises, whether it's from the homework or whether it's from the workbook. So this slide is just a bunch of examples of completing the square. You do not have to memorize this at all. This is just to practice. If you wanted to cover this up and you're given this expression, how would you find this? Same exact procedure as before. Identify your b, divide it by 2, square it, and then you get your answer. And then this is now the step-by-step procedure in completing the square, dealing with just x squared plus bx plus c, where your coefficient of x squared is just 1 right now. And so I'll go through it with you step by step, but we did the hardest part with identifying that special key and adding it to both sides. Everything is downhill from there. Okay, so let's look at example 4. We're asked to complete the square. So once again, special key. Our b value here is what? 8. So when we plug that in, we get 8 divided by 2. And then we square that. 8 divided by 2 is 4. Gotta remember that 4 is just as important as the 4 squared, which gives us 16. And so what does that tell us? Well, now when we rewrite this quadratic formula out, I'm gonna leave a little blank right after my b value. And this minus 48, I'll keep it on the left-hand side for just this step. But what we essentially want to do is we want to bring that constant, whatever that constant is, over to that right-hand side as soon as possible. If you want to do it in your first step, I highly recommend that. So now we have x squared plus 8x, have this little placeholder, is equal to 48. And the purpose of that placeholder is that's where we're adding in our new constant. Remember, we're manipulating this equation, not changing it. We're manipulating it. We're going to add 16 to both sides to keep it balanced. And now you can clearly see that that left-hand side can now be factored. This is a perfect square trinomial. Can be factored using that yellow guy that we have. It's just x plus 4, which is the same as x plus 4 in parentheses squared. So if you know that special key trick, you never have to factor, right? It'll save your whole mind from thinking, what are factor pairs of 16 that add up to 8? You already know it, it's 4. That right-hand side, we can simplify. 48 plus 16 gives you 62, 64, 64. And now that we arrived at this last row, we're back into square root property, which is our objective 1. Take the square root of both sides. So we have x plus 4 on that left-hand side. Square root of 64 is plus or minus 8. And our very last step is we're going to subtract 4 from both sides. So our final solutions are negative 4 plus or minus 8, which we can solve, right? What's negative 4 plus 8? Negative 4 plus 8 is just a positive 4. And negative 4 minus 8 is a negative 12. So these are our two solutions. We're done. Don't forget to check that both work. You plug in 4, you get 4 squared 16 plus 32 minus 48 equals 0, correct? plug in -12. -12 squared is 144 plus 96. Sorry, minus 96, it's negative. Minus 48 equals 0. Good. So both of these work. So yeah, it's bringing really all of this together now. Let's try another example, but this time let's go a little faster. We want to make sure that quadratic is all on one side. So we're going to subtract 3n from both sides, and we're going to subtract 11 from both sides. So we're looking at n squared minus 3n minus 11. Our b value is -3. So our special key is -3 over 2 in parentheses squared, which is positive 9 over 4. We set this equal to 0. And again, we're manipulating this constant. So let's bring that 11 back over to that right-hand side. So we want that excluded from that whole perfect square trinomial. Put in your placeholder. And then add in your special key to both sides. Now that left-hand side is in perfect square trinomial form, so we can factor that using our yellow. N minus 3 over 2, n minus 3 over 2, which is the same as n minus 3 over 2 squared. That right-hand side, let's put that all under one fraction. So that 11, I'm going to multiply by a fancy form of 1, 4 over 4. 11 is the same as 11 over 1. So we're looking at 44 over 4 plus 9 over 4, which gives you 53 over 4. Now we're into square root property. Take the square root of both sides. So we have n minus 3 over 2 is equal to plus or minus square root of 53 all over square root of 4 is just 2. And then last but not least, we're going to add 3 over 2 to both sides. So our final answer is n is equal to 3 plus or minus square root of 53 over 2, since they both have that same denominator of 2. And if you check it, it indeed does work. Both solutions work. Any questions? So this next part is now asking or telling us, what if we have an ax squared, meaning our a is not 1, it could be 2, or it could be 4. What happens in this case? Well, once you bring that c value, when I say the c value, like this 11 over to the right-hand side, what you want to do is you also want to divide everything by whatever that coefficient is. If it's 4, if it's 10, if it's -2. And then once you do that division, then you're back to that coefficient being 1. And then you just proceed just like we have been with these previous examples. So we might have time for this last example. Let's jump into it. We just want to make a perfect square trinomial here. So in this case is interesting because, yeah, we can divide both sides, but you'll notice that you can also pull out a greatest common factor. You could pull out, well, we want to make it a perfect square. So let's just pull out the constant 3. And then we're left with x squared minus 4x. Because technically you could pull out the 3x, but that's not our objective here. And now we're looking at this x squared minus 4x. So our b value here is -4. And then same exact procedure. -4 divided by 2 and parentheses squared. So this is the same as -2 and parentheses squared, which is 4. So what do we end up doing? We want to add 4. And so we essentially have, and what's going to happen is when we pull that 3 out, let's say this was equal to 0 or some number, we divide both sides by 3 to get rid of that. And then we have our whole x squared minus 4x plus 4. But we have no number here right now, so we can literally just keep the 3 over here. And we'll have this equal to 0. So now inside those parentheses, how do we factor that out? Our two binomials are just now x minus 2, which is the same as x minus 2 in parentheses squared. And there we have it. Write the result as a binomial squared. We have. And we're done. You're probably asking, well, how can we fit this in if we have the 3 there? Well, that's why I showed the whole division by 3, so that this is 0, and then technically, whatever you add to this side, you also need to add to this right-hand side. So having that plus 4 on this side is pretty important too. And when you have that 4 on that side, and then you end up multiplying both sides by 3, just keep in mind that this 4 is going to be multiplied by 3 as well. So maybe what I'll do is I'll change this 0 to 4 times 3, which ends up being 12. Because 3 times 4 is 12. So technically we balance the equation by adding 12 to both sides. But you don't have to know this part for this problem. You just need to know that left-hand side. We'll jump into this during our class on Wednesday. Yeah, so we'll stop here. We have a few more examples. I believe this goes up to 11 examples. So we have 2 more of completing the square, and then we have about 3 utilizing quadratic formula. So let's try this example together. Again, we want to make sure that that a value is 1, and right now our a is 3. So we can ask ourselves, can we pull out a 3 from each term? And lucky for us, in this case, we can. When we do, we get x squared minus 4x plus 2. This is all equal to 0. And then what we're going to do is let's go ahead and divide both sides by our 3. So we have x squared minus 4x plus 2 is equal to 0. And then we want to just make sure that we bring that constant over to that right-hand side. So we end up with x squared minus 4x is equal to -2. I'm going to highlight this step here because it is important to know that we've divided by 3, especially when we're asked to deal with that same quadratic from the beginning. Because at the end, we'll have to end up multiplying both sides by 3 to stick that in there. But for solving purposes, it actually doesn't make a difference when we're completing the square. Okay, so now we arrive at our b value. Take our b, divide it by 2, square it. -4 divided by 2 is -2. Square, we get +4. This is what we're adding to both sides. It's different colors here, so you're not confused. So this is our b value. This is our yellow, and then this is our blue we're adding to both sides. So we're looking at x squared minus 4x plus 4 is equal to 2. Now we can factor that left-hand side into our x minus 2 in parentheses squared is equal to 2. And then let me just highlight. And now we're back to the good old square root property. And so our final answer is just x is equal to 2 plus or minus square root of 2. And we're done. Right? Do another example together. So here we already have that constant on that right-hand side. So we can keep it there, especially since there's no greatest common factor. But that a value is 2, so what we should do is we have to divide every single term by 2 to get that a value to be 1. So we end up with x squared minus 3 over 2x is equal to 10. Now let's utilize our special key, b over 2 in parentheses squared, which is our -3 over 2, all over 2, which is 2 over 1, in parentheses squared. Keep, change, flip, and we get -3 over 4 in parentheses squared, which is just 9 over 16. This is what we're adding to both sides. So we're looking at x squared minus 3 over 2x plus 9 over 16 on that left-hand side. The right-hand side, 10 is the same as 160 over 16. And then we have plus 9 over 16. So that left-hand side, look at your yellow, this is where that comes in, is just x minus 3 over 4 in parentheses squared is equal to 169 over 16. Now we're back to our good old square root property. So we have x minus 3 over 4 is equal to plus or minus 13 over 4. Last step, let's go ahead and add 3/4 to both sides. And when we do, we end up with x is equal to 3 over 4 plus or minus 13 over 4. which is the same as 3 plus 13 over 4, or 3 minus 13 over 4, which gives you 16 over 4, which is 4, or negative 10 over 4, which is the same as negative 5 over 2. We're done. So the third and final objective for this lesson was or is being able to solve quadratic equations using the quadratic formula, which we have here. There's a song, Pop Goes the Weasel, to help you memorize this formula. I'm a terrible singer, but I will sing for you guys to help you out. But I do highly recommend that you just YouTube it. There are much better singers online than myself. But I'll zoom in on this and I'll run through it once with you guys. So I might Johnny Cash it a little bit. But we have x equals negative b plus or minus square root b squared minus 4ac all over 2a. So do that a few times, and I promise it'll be ingrained into your head like it was with mine when I was taking this class when I was your age. And this is just the straightforward way to finding your solutions of x. Obviously, you still want to check to make sure that both solutions work, but you'll get a solution every single time. So knowing that, let's utilize the quadratic formula to solve this example again. Negative b plus or minus square root b squared minus 4ac all over 2a. A is 2, my b is 9, and my c is negative 5. Negative 9 plus or minus b squared, 9 squared is 81. 4 times 2 times negative 5. Really try to make your negatives apparent because a lot of students, I think, miss them when they're writing them down. Yeah, 20 times 2 is negative 40. No, it's positive 40 all over 4. So we get negative 9 plus or minus square root of 121, which is just 11. X is equal to negative 9 plus or minus 11 all over 4. Negative 9 plus 11 is positive 2 over 4. Negative 9 minus 11 is negative 20 over 4. This just gets reduced to 1/2 or negative 5. Usually you want to put it in ascending order. So negative 5 or 1/2 are your final solutions. Do another example together. This time I'm not going to write the quadratic, but I will identify my a, b, and c. So a equals 2, b equals 10, c equals 11, and then I'll just do the straight plug-in. X equals negative b, which is negative 10, plus or minus square root b squared, which is 10 in parentheses squared, minus 4ac, 2 times 11, all over 2 times a, which is 2. And then simplify. 10 squared is 100. 2 times negative 4 is negative 8, times 11 is negative 88. 2 times 2 is 4. 100 minus 88 is 12. 12, square root of 12 can be broken up into the square root of 4 and the square root of 3. And we know the square root of 4 is just 2. So what we can do is we can factor out a 2 from each term. 2 goes into -10, -5 times. 2 goes into 2 square root of 3, just square root of 3 times, and 2 goes into 4 2 times. So our final results are -5 plus or minus square root of 3 all over 2. And we're done. The last part of this section is identifying your discriminant, which is a part in your quadratic formula. And it tells us whether we're dealing with real solutions, imaginary solutions, and if we are dealing with real, are we dealing with 2 distinct real solutions or 1 real solution? So what is our quadratic formula? It's just -b plus or minus square root b squared minus 4ac all over 2a. Our discriminant is just the b squared minus 4ac, not even the square root. Maybe I'll squiggly it. That's our discriminant here. And how do we get these 3 different cases? Well, if we take the square root of 0, we're only going to get 1 real solution. Positive 0, -0 is the same as just 0, 1 real solution. If we take the square root of 16, well, we get 2 distinct real solutions, +4 and -4. That's when our discriminant is greater than 0. And then if we take the square root of -9, we have no real solutions. That enters into our imaginary world of 3 imaginary, 3i. That's when our b squared minus 4ac underneath that square root sign is negative. So now let's apply our knowledge, new learned vocabulary word, which you want to make sure you definitely have written in your notes. We'll use a concrete example for our last example of today's lesson. There's 3 parts to it. So again, A is 1, B is 2, C is -1, discriminant b squared minus 4ac. We want to just figure out what is the pattern here. 2 squared minus 4 times 1 times -1. 4 plus 4, this gives us 8. Oh, 8. What do we know? If our 8, this is greater than 0, it's positive. So we get 2 real distinct solutions. Next one, A is 4, B is -12, C is 9. -12 in parentheses squared minus 4 AC. 144 minus, we have 36 times 4 is 144. That gives us 0. So our discriminant is 0. Means it's equal to 0. So we have 1 real solution. And I like to add in with the multiplicity of 2 because that solution is just being repeated. 1 real solution. Last but not least, I think you guys are catching the drift here. Probably gonna have imaginary at this point. So we have negative 2 squared minus 4 times a times c, which is just 4 over 1. So we get 4 minus 16 over 3, which is definitely going to be less than 0, which means we have no real solutions, only imaginary. So that completes today's lesson. These are some extra workbook problems for you guys to check out for additional practice. Highly, highly, highly recommend you do this in addition to your online homework. Let me know if you have any questions. We only have 2 sections left and then we're done with the whole curriculum. So we're really in the home stretch now. All right, take care.